Hello everyone, welcome back to the Computer Networks course. Right now we are going to start a new chapter which is the network layer, and we are going to focus on data plane. And as for your information, in this course the network layer will be divided into two parts. The first one in this chapter is data plane, and then in the next chapter we are going to focus on the control plane. All right, so this is our goals in this chapter. We'll talk about some stuff, focusing on data plane in network layer. First, we talk about the network layer service models. Although we are going to focus only on the internet service model, which is best effort, and then we'll talk about the forwarding versus routing. This actually defines the difference between the control plane and data plane. All right, so forwarding is in the data plane, and routing is in the control plane. And then we'll talk about how a router works. Although I'm going to skip most of the parts in this section, I'm just going to explain how the forwarding is done in the router. So that's it. And then the biggest part will be in the addressing. So we'll talk starting from the structure of IP address, and also we are going to talk only about the IP version 4. Okay, so from the structure of IP address version 4, and then how we are doing subnetting, why we need subnetting, and how different techniques for doing the subnetting, and then how we obtain IP addresses like for DHCP and so on. And then we talk about the generalized forwarding. This is we'll talk later. This is done in SDN. It's called SDN, software defined networking. This is a new approach. Well, it's not new, but it's relatively new. Started around 15 years ago, 2006, from some people in Stanford University. And then we talk about internet architecture in general. All right, so in the implementation part, we'll talk about the IP protocol, especially on the header structure, and then NAT, okay, network address translation. Well, I'm sure without you are realizing, you already using this NAT, and actually almost all of this stuff that we talk about, then you already use it without you realizing it. And then finally the middle boxes. So this is related to the virtualization functions. You know, so similar to what's happening in the virtual machine servers and so on, there is also virtualization in the network. So this is about that. All right, so this is the roadmap or outline of this chapter. We start with the overview and differences between data plane and control plane, and we also talk about the service model in the network layer. And what's inside the router? As I said, I'm going to skip a lot of technical stuff about the routers. I'm just going to talk about the mechanism, forwarding mechanism. The longest prefix matchings. And this is the biggest part of this chapter, the IP or Internet Protocol. The IP actually stands for Internet Protocol. So starting from the datagram format, and then the structure of IP address, addressing, subnetting, a lot of stuff there. And then the HTTP, how the HTTP mechanism is done, and then network address translation, and IPv6 will be, we'll talk about that very, in a very little portion. And then next, we'll talk about the generalized forwarding. This is done in SDN. Well, what is SDN will be explained later in this overview. And then finally, middle boxes. Yeah, as I said, this is related to the virtualization done in the networking stuff. All right, now as usual, we start with this figure. Before, when we talk about the application and then the transport layer, they are all talking about the end-to-end. Okay, they are sitting at the end device or end system, the client and server or the hosts. Okay. Okay, so now when we talk about the interaction between the transport layer and the network layer, or let's say the lower layer, so basically at the sender side, the sender encapsulates the segment. Segment is located at the transport layer, and we actually encapsulate with the IP header or network layer header, and it becomes datagrams. Datagrams is, again, it's a term used at the network layer, telling that this is the packet. Okay, so it becomes the datagrams and then passes to the link layer, to the lower layer. And at the receiver delivers segments. Okay, so basically what happens at the network layer, it takes out or decapsulate the IP headers and then deliver it to the transport layers. Okay, now, yeah, as I said before, when we talk about the transport layer, they are sitting only at the end devices. But then now, the function is already happening at every internet devices, hosts and routers, especially hosts and routers. Okay, so it's not just end devices like this, for example, the client and the servers, but also at this devices, the round device with the X, X symbols. Okay, and it's not this device, the switch, because switch only up to the link layer. We'll talk about that in chapter 6. Okay. So in routers, the important functions happening at routers are examining the header fields of the IP datagram. So because what happened is the same as, for example, like in the transport layer, it needs to know what is the destination port or the source port numbers. Okay, but in router or in the network layer, so it needs to know what is the destination IP address, because then it needs to match with the forwarding table, and then it will do the forwarding, right? Yeah, datagram input from input ports to the output ports. So this is exactly the forwarding function. All right, so now we talk about the two network layer functions. As I said before, there are forwarding and routing. Okay, so forwarding, as I said before, it's moving packets from router inputs link to appropriate output link. So this is really related to the incoming packet data. All right, so that's why this is a function that happens at the data plane. Okay, and while routing, it is like determining the whole route from source to destination. But this is not done, at the same time or when the packet is coming. So it's done parallelly or even before. It is also not done for a single packet or a single IP address. So it's for a whole bunch of IP addresses, source IP addresses to destination IP addresses, and then we'll talk about various routing algorithms in the next chapters. All right, so if we take the analogy of taking trip, the forwarding is like the process of getting through a single interchange. Like, for example, like when I arrive at the traffic light, so whether I take I turn right or turn left or go straight, so this is the forwarding. Okay, or let's say if I take different modes of transportation, so for example, like I take a walk from my home, and then I take I don't know, angkot, for example, and then which angkot number, and then I stop at the bus stop, and then I take another bus, which is specific bus number, and then I arrive at the train station, and then I take the train to the specific destination. Then the process of getting off from one in one place and then getting up to another transformation mode is called forwarding process. And while routing is the process of planning the whole trip, from source to destination. So I'm going from my home and taking this path and take a walk, and then at this point, specific point, then I take another transportation mode, and so on and so forth until I arrive at the destination. Now, okay, so having said that, as I said, we have different parts in the network layer: data plane and control plane. So data plane is something happens locally. Okay, it's a per router function. It happens really at the at the local router, and it's the task is just to forward incoming datagram. Okay, forward to the output port, the appropriate output port of the routers. Okay, so this is related to the data. So incoming data or incoming datagrams, and then we try to forward it to the appropriate output port. While the control plane is not enterprise logic, meaning that okay, although like we have, as we talk later, there are different approaches. This control plane can also implemented at each router, but actually it is trying to map the whole topology of the network. So it's trying to get the view of the overall network topology, and then it tries to determine the best route taken by a packet from specific source to specific destinations. Okay, then yeah, then we come to this approaches, two different approaches in the control plane. So basically, yeah, especially in the control plane, and if we talk about that, it is how the control plane and data plane are separated. In the first approach, this is the traditional routing algorithms implemented in each routers. Okay, so it's like so the router has all the functionalities. Okay, even the routing algorithms are implemented there. Okay, that's why, as I said before, although it is network-wide logic, but it can be implemented distributedly in each and every router. Okay, and then the new approach is called software-defined networking, or SDN. The network or the routing algorithms or the forwarding or whatever it is implemented in remote servers. Okay, and all this information will be sent to the each router. Okay, so we start with the router control plane. Um, so basically, in the field routing algorithm is installed or is run in each and every router. Okay, so and also it, of course, like as we said before, the data plane is happening locally. So basically, in the router control plane, the control plane and data plane are in the same router. Okay. All right. So in the software-defined networking control plane, the control planes is located in the remote server. So all these routing functionalities or forwarding functionalities like the flow, okay, is run at this remote controller, and then the remote controller sends the information about it's called flow table or forwarding table to each and every switch. So in this SDN, this term is not called router anymore, but it's called switch. All right, so now we'll talk about the network service model. Although there are different types of service model in network layer, but the mostly used or the most common one is the internet best effort service model. And in this service model, there is no guarantee on the successful datagram delivery, unlike TCP, for example. And also there is no timing or order of delivery. So there is no, let's say, for example, like delay requirement. So it doesn't give any guarantee on the delay, minimum delay, for example. Like, and also there is no guarantee on the bandwidth available. So uh, and these two types of requirements are very very much needed for multimedia applications like video streaming and so on and so forth. So yeah, if some maybe institutions or organizations really need this um, minimum delivery, minimum delay, and minimum bandwidth, maximum delay and minimum bandwidth, then they may use different types of service model. Which is yeah, we're not going to talk about that in this course, but you can read more information about that. Well, it's also not that much, but you can take a look at that. There's diff serves and in serves, for example, and ATM is not ATM. ATM is asynchronous transfer mode, if I'm not wrong. It was the competitor of the Ethernet switch, but then it's not it's not successful. So and, the Ethernet is more successful or more adapted than the ATM. So there is only Ethernet based technology at the moment. All right, now finally we talk about the reflections on the best effort services. it is a simple in mechanism and has allowed internet to be widely deployed. This is the fact. And then sufficient provisioning of bandwidth. So basically, we just try to measure or try to estimate the minimum bandwidth requirements required for different applications. For example, like real-time applications, video streaming, video, voice, interactive voice call, and so on. And then this can be replicated at the application layer distributed services, for example, like data centers, and content distributed networks that connects close to the client's networks. Okay, so we can provide services in multiple locations, and this is very true. Like for example, Google or YouTube, um, they have um, data centers all around the globe, and even the content they can also put the contents everywhere around the globe. So for the users, in one part of the geographical area, they don't have to access the from the server at the US, for example. But then, for example, like the Indonesian user, they can access the server from the Singapore or maybe from other Asian countries. All right. So and the congestion control of elastic surfaces helps. Yeah. So this is also we can implement congestion control for the elastic. Elastic means like the non-real time services. So I think that's it for now. For the overview, we'll continue with the next uh, section about the forwarding functions inside the router. So see you again in the next video.